Dear students, today we start a new chapter biomolecule. Biomolecule. So from the name biomolecule, bio means what your life. So and molecules basically here we take the organic molecules. You will take what organic molecules. So biomolecules are the organic molecules which are constitute as the essential component of life. Life is what in your plant and animal, living beings. So those organic compounds which are the essential constituent of the life, which are utilized for the survival, growth, development, and ability to reproduce of a living organism are called the biomolecules. Like your carbohydrates, like your proteins, like your amino acids, your fats, oils, lipids, peptides, nucleic acids, all are these compounds which are essential for living organism to utilize for say growth, development, survival, and ability to reproduce. Okay, so the first one is carbohydrate. Okay, carbohydrate. Carbohydrates. What are carbohydrates? Carbohydrates are the optically active polyhydroxyaldehyde or polyhydroxyketone. Okay, polyhydroxyaldehyde or polyhydroxyketones, which are the essential constituent of the cells, which provide all the energy. Okay, and which are the most essential part of the nucleic acids. Okay, so these carbohydrates, for example, glucose, fructose, sucrose, ribose, cellulose, okay, starch, many are there. So they are the different kind of carbohydrates, the biomolecules, which are the polyhydroxyaldehydes or polyhydroxyketones, and are essential constituent of the living cells. Okay. So these carbohydrates are classified on different heads on the basis of hydrolysis product, on the basis of taste and nature, on the basis of reducing nature. The most important ones are this one, on the basis of hydrolysis product. That means carbohydrates on hydrolysis, whether again giving some other carbohydrates or not, depending upon that, the carbohydrates are being classified as what? As what? Monosaccharides, oligosaccharides, polysaccharides. So monosaccharides are the single sugar units which on hydrolysis are not giving any further sugar, or you can say which do not undergo hydrolysis are called the monosaccharides. Similarly, oligosaccharides are those which on hydrolysis gives 2 or 3 or 4 monosaccharide molecules, and the polysaccharides are those which on hydrolysis giving more than 4 monosaccharide units, or they are giving a number of monosaccharide units. Now, on the basis of taste and nature, the carbohydrates are of 2 kinds: sugars, non-sugars. Sugars and non-sugars. Sugars are those carbohydrates which are sweet to taste, crystalline in nature, and soluble in water. Like what? Your glucose, your fructose, sucrose, many more. Non-sugars are those carbohydrates which are tasteless, amorphous in nature, and not soluble in water. Like water, cellulose, starch, etc. Okay. Now, on the basis of reducing nature, those carbohydrates which are reducing tolerance reagent and fairing solutions are called the reducing sugars, and those are not reducing the tolerance reagent and fairing solutions are called the non-reducing sugars. Okay, so reducing, okay, your glucose, fructose, okay, another value non-reducing, okay, cellulose, starch, okay. In fact, here in this case we can say the polysaccharides are basically non-sugars generally, and oligosaccharide and monosaccharides are generally sugars. Okay, all the monosaccharide and oligosaccharides are sugar in nature. Okay, whereas the polysaccharides are generally non-sugars in nature. Okay, now we will discuss different kind of mono, oligo and polysaccharide molecules. Okay. Monosaccharides. Monosaccharides. So monosaccharides are those carbohydrates which are not giving any monosaccharides for their units on hydrolysis. Okay. For example, audio we have glucose, we have fructose. Okay. Number one, glucose. So glucose are the monosaccharides. Okay. C6H12O6. Glucose is the monosaccharide molecules which is having formula C6H12O6, and it contains an aldehyde group, CH group. So this is also called what, aldose. Whereas fructose is also C6H12O6. It contains a keto group called what? Ketose. So glucose is an aldose and fructose is a ketose, right? And we can prepare this glucose from sucrose C12H22O11 plus H2O plus H2O hydrolysis in acidic medium. We get what? C6H12O6 plus C6H12O6. This is called what? Sucrose. It's called what? Sucrose. This is what? Glucose and fructose. So we can find glucose and fructose in the combined form in sucrose. Sucrose is also called what? The cane sugar. Okay, so sucrose contains both glucose and fructose in the combined form. Also, I can get C6H10O5 and starch. Okay, plus H2O and H2O. You can convert C6H12O6 and starch is what? Glucose. So glucose also we can get from the starch on hydrolysis. Okay. Similarly, fructose you can get here from sucrose. From sucrose on hydrolysis of sucrose we are getting what? Fructose along with your glucose. Okay. So glucose and fructose are the monosaccharides. Glucose and fructose are the monosaccharides. Glucose we can obtain from sucrose by hydrolysis, and also we can get glucose from the starch by hydrolysis. Clear? And this glucose. Now the glucose, the configuration of glucose is relative to glyceraldehyde can be what? D and L. Okay. See, if I add CHO 2, 3, 4, 5, 6. Okay, now again CHO CH2. Now see, H, OH, OH, H, HO, H, OH, H. Or I can write OH, H, OH, H. Here see, this is your glucose, this is also your glucose molecule. If we compare this with your glyceraldehyde, see, we have CHO, C, OH, H, CH2OH. This is what glyceraldehyde, and here see this OH. This also is to the right side. It's called D-glyceraldehyde. It's called D-glyceraldehyde. And if I write CHO, CH2OH, it's called L-glyceraldehyde. Now, if in the glucose molecule this first asymmetric carbon, the OH group is in the same side of the D-glyceraldehyde, is called D-glucose. D-glucose. You see, this is the first asymmetric carbon, this one. Here the OH is the same side to the L-glyceraldehyde. This is your L-glyceraldehyde, which is called L-glucose. So, if in the glucose molecule, the first asymmetric carbon OH group is attached to the same side of the OH of the D-glyceraldehyde, that is called D-glucose. So this is relative configuration. Okay, D-glyceraldehyde, and if the first asymmetric carbon, the OH group is attached to the same side of the L-glyceraldehyde, that is called L-glucose. So this is what D-glucose, this is what L-glucose. Okay. Now this D-glucose again having two different isomers. So one part this D-glucose or your alpha form or your beta form. So these two forms are having different specific rotations called the muta rotation. Depending upon the specific rotation, again the D-glucose is your alpha and beta. So alpha D-glucose and beta D-glucose. Clear? Next is your oligosaccharides. Okay. Oligosaccharides are the carbohydrates obtained by the combination of a definite number of monosaccharide units by the removal of definite number of water molecules. Okay, and these on high lysis gives you 2, 3 or 4 monosaccharide molecules. If the carbohydrates on high lysis gives you 2 saccharide molecules, so 2 monosaccharide molecules, so that is called disaccharide. If it gives you 3, we call it trisaccharide, and if it gives you 4 monosaccharide molecules, so on high lysis this is called tetrasaccharide molecule. Okay, so if you go for disaccharides, disaccharides are those carbohydrates, okay, which on hydrolysis gives you 2 single monosaccharide molecules, like sucrose, maltose, lactose. Okay, you go for sucrose. Sucrose is the disaccharide which on hydrolysis gives you 2 single sugar units, 1 alpha D glucose and second beta D fructose. That means sucrose is formed by the combination of alpha D glucose molecule and beta D fructose molecules. Okay, so here the alpha D glucose and beta D fructose are combined, are undergo condensation with removal of water molecule. And here there is a new bond formed, ethyl bond, you can say. C1 of the glucose and C2 of the fructose are combined through oxidation called the ethyl bond. And this is called glycosidic linkage. Okay, so alpha D glucose and beta D fructose at C1 and C2 are combined through glycosidic linkage where we are getting the sucrose. Okay, so C12 has 22 O11 sugar is also obtained from cane sugar. Okay, also so on hydrolysis we are getting what C6H12O6 plus C6H12O6 glucose and fructose, alpha D glucose and beta D fructose. Okay, so alpha D glucose and beta D fructose combined at C1 and C2 through the glycosidic linkage to form the cane sugar, right? Now next maltose. Maltose occurs as the malt sugar. Maltose sugar C12 H22 O11 also called malt sugar. So here maltose is the malt sugar which on hydrolysis gives you a number of alpha D glucose units. That is here the number of alpha D glucose units are condensed with removal of water molecule to give the maltose. Here the C1 of 1 glucose, C1 carbon of 1 glucose and C4 carbon number 4 of the another glucose units are condensed to form the glycosidic linkage. Okay, so here you can write C6H10O5N plus H2O diastase enzyme C12H22O11. Maltose 2. Okay, C12H22O11 and called maltose. Okay, so next is lactose. So lactose is also called milk sugar C12H22O11. So this lactose is also basically found in the milk of the animals. So this is also called milk sugar. Okay, and this is the condensation product of alpha D glucose and beta D galactose. Okay, here also same the C1 and C4 glycosidic linkage formed between the alpha D glucose and beta D galactose. Okay, so here C12H22O11 lactose H2O C6H12O6 or C6H12O6. Okay, glucose and fructose. Clear? So these are about different kind of disaccharides, sucrose, maltose and lactose. Okay, now then we will go for the polysaccharides. So polysaccharides are the carbohydrates that contains a large number of single monosaccharide units, and these are the carbohydrates which on hydrolysis gives you a number of single monosaccharide units. Okay, like for starch, cellulose, glycogen. Okay, starch, cellulose and glycogen. C6 hexane O5N. C6 hexane O5N. Now the starch, cellulose and glycogen, these are the three different polysaccharides. Okay, so all are containing what you know, a number of monosaccharide units. The starch we found in the form of food in potato, rice, corn, etc. So starch is the polysaccharides which are formed by the plants which the animals are using for the purpose of food. So animal can consume this is starch. Okay, but cellulose is also polysaccharide, but it is found in the form of wood. Okay, wool, cotton. Okay. Different parts of plants. So these are the cellulose which we cannot consume. So this we can use for the purpose of household furnitures. Okay. And the glycogen are the polysaccharides which are stored in the liver, muscle and brain. So whenever we are having the excess calories, that excess calories are reserved in the form of glycogen in our liver, muscles and brains. And then when we are in the position of fasting, so when you need energy but you don't have the food, at that time this glycogen present in the liver, muscles and brain can convert into glucose, and that you can utilize for the purpose of working. Okay. And one thing remember here, this starch, the polysaccharides, is consisting of two things. One is amylose and also amylopectin. These are two important things. The starch contains the amylose and amylopectin. Okay, so these two units are there. In the amylose, the single sugar units are joined by straight chain, but in the amylopectin, the single sugar units are joined through straight as well as branch chain. Okay. Now this amylose is soluble in water, but amylopectin is not soluble in water. Now the combination of these two chains is called what? Starch. Okay. Now, what are the functions of the carbohydrates? What are the functions of carbohydrates? Number one, body fuel. Our body, we are doing work with the help of energy, and this energy is being supplied by the carbohydrates. Okay, carbohydrates supply us energy. So we can say carbohydrates are the body fuels. Number two, essential constituents of cells. So whatever the cell plasmas are being manufactured or being prepared from the carbohydrates. Okay. Essential parts of nucleic acids. Okay, the nucleic acids contain the ribose sugar. Okay, pentose sugar. So this will discuss later on. Okay, nucleic acids are also called the carbohydrates. So this is the summary. This is the summary of the class. Okay. See the carbohydrates. Already we have discussed. Carbohydrates are classified on the basis of three things. One is on the basis of hydrolysis, on the basis of taste and nature, on the basis of reducing nature. On the basis of hydrolysis, carbohydrates are monosaccharides, oligosaccharides, polysaccharides, monosaccharides, glucose, fructose. Oligosaccharides can be disaccharide, trisaccharide, tetrasaccharide. Disaccharides is sucrose, lactose, maltose. Trisaccharides we have raffinose, and tetra we have stipose. Then polysaccharides you have starch, cellulose, glycogen, gum, etc. Okay. Similarly, on the basis of your taste and nature, we have sugars and non-sugars. Sugars, all the mono and oligosaccharides like also glucose, fructose, sucrose, and non-sugars all polysaccharides like cellulose, starch. Again, on the basis of reducing whether the carbohydrates are reducing the tolerance region to fighting substance or not. Accordingly, these are two: reducing sugar and non-reducing sugar. Reducing sugars are those glucose, fructose, maltose, lactose, and non-reducing your sucrose, cellulose, starch. Okay, so this is the summary of this classification of carbohydrates. And next we will discuss what is the amino acids. Okay, thank you.